These are the frequently asked questions for pre-calculus for the first day of review for Chapter 8. And I've got a couple of parabola problems that I'm looking at here because, it's the first thing we studied in this chapter and our memories are probably a little faded here. So this one says we are to find an equation in standard form for the parabola that satisfies the given conditions. We have a focus at 3, 4, so you want to go ahead and at the very least make a sketch of this stuff. So focus at 3, 4. And it has a directrix of y equals 1. So y equals 1 is the horizontal line through 1. Now, what does that do? Well, the directrix, remember root word direct, is directions. It says don't go this way, go the other way. That means this one, this particular parabola, is going to open up. And if it opens up, we need x squared. Remember with parabolas, you don't square both of them, you just square one or the other. So we've got squared over there. Now we have to figure out where the vertex is. That's really important, and it's always halfway between the focus and the directrix. So we take a look here and we see we have 1, 2, 3 units there. That means we're going to end up with a little bit of fraction action. So if we remember that this line is y equals 1, we know that it's going to be 3 something. And that something has to be halfway between 1 and 4. So you could just take 1 plus 4 and divide it by 2. In fact, you could use a midpoint formula for these and it'll work out. So we have 5 halves. So it's going to be at 3, 2 1/2. But for formula purposes, we'll leave that exact. We'll leave it at 3 5/2. So far, we know that we can put 3 in for h, and we can put 5 halves in for k. Ooh, that's a goofy looking 5. There we go. That's a little better. So what we need is to find p, and p is the distance from the focus to the vertex. Not a hard thing to do now that we have this all lined up and set up, because we can see, yeah, they're both going to be 3. We just need to know how far is it from 4 to 5 halves. So from 4 to 5 halves is 4 minus 5 halves, which would be 8 halves minus 5 halves, which is 3 halves. So that is the distance from our focus to our vertex. And that needs to go right here. Now, standard form is we go ahead and multiply out 4 with whatever we have for p. So 4 times 3 is 12. 12 divided by 2 is 6. And again, only one, either the x or the y, is squared, never both. X squared for up and down, and then y squared for right and left. So there it is. X minus 3, the quantity squared, equals 6, times the quantity y minus 5 halves. 24. Find an equation in standard form for the parabola that satisfies the given conditions. We have a focus at 2, -3. Not getting a lot of fair play by the smartboard at the moment. Maybe I'm just writing too fast for it today. There's 2, -3. Directrix is x equals 5. 1, 2, 3, 4, 5. And just like the last one, we want to think, okay, the directrix is supposed to give directions. It's a line that says, don't go this way, go the other way. This is left opening. So we're going to have y minus k squared this time. And we have to keep in the back of our mind that we need to use a p-value that is negative. P is that directed distance. So if we find p and it comes out positive, we know better. We need to slap a negative in front of there. So now we need to figure out where, oh where, is our little vertex. And that's going to be halfway between our 2, -3, I'll write it over here so it's a little easier to see, and then the line x equals 5. So we take a look at this and we realize it's going to be something -3. But what we have to do is figure out what's halfway between a 2 and a 5. So 2 plus 5 divided by 2 7 halves. So we have our little vertex here at 7 halves, -3. And we can start writing this because we know that it's going to be y minus a -3, which will be y plus 3 squared equals 4 times p times x minus 7 halves. Last piece of the puzzle is to figure out that distance p. Remember that directed distance p. Now we just said this is the coordinates for vertex right here, and we know that this is the coordinate for the focus. Let me get that vertex on here so we can actually see that. I was thinking it would just be really best here if we had a visual on what we were supposed to do. So there was our 2, -3, and then we had 3.5, -3 right there, because I need everybody to be able to see that. Now, hopefully you're looking at that and you're thinking, oh, that's 1.5. But you know what? We can do the math by just taking 2 minus 7 halves. And of course, 2 is going to be 4 halves minus 7 halves, so that'll be a -3 halves. Now notice that is the directed distance. If you did it the opposite way and took 7 halves minus 2, you'd get 3 halves. But you'd think, oh, wait a minute, I need this to go left, so we need that p-value to be a -3 halves. So y plus 3 squared equals 4 times -3 halves times the quantity x minus 7 halves. And we would multiply out that 4 times -3 halves and get -6. And then we have it. So the quantity y plus 3 squared equals -6 times the quantity x minus 7 halves. And it was just those two that you had asked for.